To Geometrix Galaxy students, in this video we are going to watch grade 10 triangles theorem 6.1, that is basic proportionality theorem. Now let us see what is given in the theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So let us see in detail. Now listen to the explanation, students. Now ABC is a triangle. Okay. So in this triangle, if a line is drawn parallel to one side of a triangle, that is DE is the line drawn parallel to one side of the triangle BC to intersect the other two sides in distinct points. So this DE intersect the other two sides in the distinct point D and the distinct point E of the other two sides. We need to prove the other two sides are divided in the same ratio. Okay, that is this part AD divided by DB is equal to AE divided by EC. Let us do some constructions to prove this theorem. Now we should join DC and this BE. Now we can see two triangles between the two parallel lines is DE and BC. The BDE and DEC. Now triangle BDE and DEC are on the same base D and between the same parallel lines DE and BC. You have studied in your grade 9, triangles are on the same base and are lying between the same parallel lines, then the area of those triangles are equal. Therefore, we can write area of triangle BDE is equal to area of triangle DEC. Let this be the first equation. You see the triangle ADE. Draw EN perpendicular to AD. Then you all know area of triangle is equal to half into base into height. So use that formula and find area. Area of triangle ADE is equal to half into base, here is AD, and height of the triangle ADE is EN. So half AD into EN. Area of triangle BDE is equal to half into base, this base BD, and height EN. This is the height of the triangle BDE because BDE is an obtuse angle triangle. Height of the triangle lies outside the triangle. Therefore, height is EN. Now, we will divide area of triangle ADE by area of triangle BDE, which is equal to half into AD into EN divided by half into BD into EN. Here, we can cancel half and half, EN and EN. Therefore, area of triangle ADE divided by area of triangle BDE is equal to AD by BD. This is our equation 2. Now draw perpendicular DM to the base AE. Next, using the formula of area of triangle, find the area of triangle ADE by keeping the base as AE and the height DM. Area of triangle DEC, this is DEC. So area of triangle DEC is equal to half into the base EC into the height dm. Since it is an obtuse angle triangle, the height dm lies outside the triangle. Now, area of triangle ADE divided by area of triangle DEC is equal to half into AE into DM divided by half into EC into DM. So now we can cancel half and half. Next DM and DM will get cancelled. Therefore, area of triangle ADE divided by area of triangle DEC is equal to AE by EC. This is our equation number 3. Now from equation 1, 2 and 3, we can say that AD by BD is equal to AE by EC. This is because you see this DEC triangle area and BDE triangle area are equal. It is shown in equation 1. Therefore, we can say AD by BD is equal to AE by EC. Hence, we have proved the ratio of the other two sides of the triangle are equal.